Okay guys, and welcome to today's video. We are looking at chapter 1I from the year 10 textbook.
Perpendicular. That means at 90 degrees to one another, right? So these lines here would be perpendicular to one another. And of course, parallel means that they run in the same direction and do not touch ever. Information, well, we can actually gain a couple of things. The first thing we can gain, looking at parallel lines, well, if we were to put these on the same axes here, well, what you would see, right, is that they have the same slope, don't they? Because they are never going to touch each other, right? And if they never touch each other and they have the same slope, then we can therefore say that their gradients are the same. So we could say m1 equals m2 for parallel lines there. So just to reiterate, parallel lines have the same gradient. Perpendicular lines, however, they do not have the same gradient. They have an inverse relationship to their gradient. So, for example, they perpendicular lines, right? They actually relate to one another using this formula here, which is m1 times m2 is going to be equal to -1. Or we could also, if we were to divide by either m1 or m2, let's say we divided by m2 here, we would get m1 is going to be equal to -1 over m2, and vice versa, we could have m2 is equal to -1 over m1 there. So these are maybe some things to write down at the start of the chapter. So parallel lines, the gradients are equal to one another, and perpendicular lines, they are related inversely to one another. That is what we're going to do. Okay, so then, yeah, jumping straight into it, guys, what we have is we've got question 1a here, and 1a, well, question 1 says, decide if the graph of each of the following pairs of rules will be parallel, perpendicular, or neither. Okay, so for the first one, 1a, we have y equals -2x minus 3, and we also have y equals a half x plus 2. Okay, so straight off the bat, we know that -2 does not equal a half, right? Because these are the gradients, the m values, y equals mx plus c, and m is the gradient, right? So we know that -2 and -2 does not equal a half, so we can say 2 not equal a half, therefore not parallel. However, we can now test to see whether they are perpendicular. So we can say -2 times 1 over 2 equals -1, right? And well, in order to make this easy to multiply, we just put that -2 over 1, and then we get, well, top by the top, bottom by the bottom for multiplication of fractions. So -2 times 1 is going to be equal to -2, and 1 times 2 is 2. And that, well, -2 divided by 2 is going to be -1. So we could therefore say that this is going to be a set of perpendicular equations. Okay, every second question, doing 1c now. 1c, we have the equations 4x plus 2y equals -4, and we also have the equation x minus y equals 3. And, well, these are in the the intercept form, which is ax plus by equals c. And we know from past chapters that the gradient, when we do it in this form, is going to be -a over b. Right? So for the first equation here, where we have 4x plus 2y, we can say m is going to be equal to negative 4 over 2, which in this case would be, well, it would be negative 2 over 1, which is negative 2. For the other one, well, we can say m is simply just going to be, it'd be negative 1 over negative 1, which is 1. And because, well, we can now say because negative 2 does not equal 1, we can therefore say not parallel, or just para for short. And the next test for perpendicularity is to times them together. So m1 times m2 equals neg 1. And in this case, it'd be neg 2 times times just regular 1, which is going to be 2 times 1. Negative 2 times 1 is neg 2, which does not equal negative 1. So not perpendicular either. Perp for short. So therefore, we can say neither applies for this one here. Okay, jumping into it now, we're going to question 2a. In 2a, we have the equations y equals 3x minus 1